For the past couple of years, our relationship with AI has pretty much been a conversation, right? We type in a prompt, it gives us an answer. We ask for a picture, and boom, it generates one. But what if the AI could do more than just talk? What if it could actually act? Okay, let's dive into this because we are on the verge of a massive shift, moving away from simple predictive AI and into the new world of autonomous agents.
And this quote right here, it just hits the nail on the head. We're moving beyond the raw potential of these language models and into making that potential truly practical. It's all about turning the AI's ability to think into an ability to actually get things done out there in the real world.
So, to really get what's happening, we need to see exactly what's changing. Think of it like this. It's the difference between an AI that can answer your questions and an AI that can actually go and complete your to-do list for you.
Now, what's really key here is the difference in agency. On the one hand, you've got the predictive AI we're all used to. It's super powerful, no doubt, but it's passive. It needs a human to direct every single step. But on the other hand, you have AI agents. These are designed from the ground up for autonomous problem solving. You give them a goal, and they figure out all the steps to get there, completely on their own.
So how in the world does an agent actually do all this? What are the building blocks? Let's break down its core anatomy. And honestly, it's simpler than you might think. It really just comes down to a brain, some hands, and a nervous system to connect it all together.
First up, you've got the brain. This is the large language model itself, like a Gemini or something similar. This is the core reasoning engine. It's the part that processes information, understands the goal you gave it, weighs the different options, and ultimately makes the decisions.
But of course, a brain can't do much without some hands, and that's where tools come in. Tools are things like APIs, bits of code, or connections to a database. They are what allow the agent's thinking to break out of its digital box and actually interact with the world. To search the web, shoot off an email, check a calendar, or update a customer's record.
And the thing that connects the brain and the hands is the nervous system, which we call the orchestration layer. This is basically the manager for the whole operation. It runs the agent's main loop, it handles the planning, it manages memory, and it decides when it's time to think and when it's time to use a tool to go and act.
And this brings up a whole new way of thinking for developers. You're no longer a bricklayer, meticulously coding every single step of logic. Instead, you're more like a director. You set the scene with your instructions, you choose your cast of tools, and you provide the context. Your job is to guide this autonomous actor to give the performance you need. It's a huge shift.
So, we've got the parts. The brain, the hands, the nervous system. Now let's look at how they all work together in this continuous cycle to actually get something done. Every single agent follows this basic 5-step process. First, it gets its mission, the goal. Then, it scans the scene, pulling in context from its memory and its tools. Step 3, it thinks. It comes up with a plan. Step 4, it takes action by using one of its tools. And finally, the most important part, it observes the result of that action and then repeats the loop. You can really boil this whole thing down to a simple but powerful cycle. Think, act, observe.
Let's make this super concrete with a simple example. A customer asks, "Where's my order?" Now, a simple AI might just get stuck, but an agent thinks it through. It makes a plan. First, I'll identify the order in the database. Second, I'll track the package using the shipping API. And third, I'll report the status back to the customer. Then it just uses its tools to execute that plan step by step until the job is done.
Now, like with any tech, agents exist on a spectrum. They can range from really simple tool users to these incredibly complex collaborative systems. So let's take a look at the different levels of autonomy that we can expect to see.
Okay, so you can see the progression here. Level 0 is just the basic reasoning model. It's like a brain in a jar with no connection to the outside world. Level 1 is when it can actually connect and solve problems using basic tools. At level 2, it becomes a strategic planner that can handle really complex, multi-step goals. Level 3 is where things get interesting. You get a whole team of specialist agents working together. And then the frontier, level 4. That's a self-evolving system that can actually create new tools and new agents to solve problems it has never even seen before.
And this brings us to a really critical question. All this power, all this autonomy, it's incredibly exciting, but it also opens the door to risk. I mean, if these agents can take actions in the real world for us, how do we make absolutely sure they do what we want them to do, and nothing else?
This last piece of the puzzle is probably the most important one, building the guardrails. How do we govern this new workforce of digital agents to make sure that we can actually trust them? At the heart of this problem is something called the trust trade-off. To make an agent useful, you have to give it power and autonomy.
But every single bit of that power introduces risk, the risk of it going rogue or accidentally leaking data. The real trick is finding that perfect balance, a leash that's long enough for the agent to do its job, but short enough to keep it, and us, safe.
So the best way to handle this isn't to just blindly trust the AI. It's to use a hybrid approach, a kind of defense in depth. First, you have what are called deterministic guardrails. These are just hard-coded rules, like a policy that blocks any purchase over $100, no exceptions. But then you add reasoning-based defenses, where you're actually using AI to secure AI, like a special guard model that reviews an agent's plan before it runs it to flag anything that looks risky. We are truly at the dawn of a new era in computing, moving from simple conversation to real action. The systems we're building are becoming less like tools that we operate and more like partners that we direct. And that leaves us with one last thought to chew on. When your AI is no longer just an assistant, but a true agent, what mission will you give it?